The following is the video solution from JSDT Solutions. Question 2 says, Formula 1, aka F1, race car drivers have to endure high G-forces at extremely high temperatures. They tend to lose close to 4 kg of weight after every race. Okay. Question 2.1 says, the table below shows the total weight lost by 40 different race car drivers after the duration of one race. Okay, so this is the interval of weight lost in grams and then the number of drivers that fall into that particular category. So 2.1.1 says, write down the modal class of the data. So the modal class means the class that appears the most. So if a class appears a specific amount of times, it will show in the number of drivers that were in this class. So the modal class would be the class that has the highest number of drivers, which we can see is 15. So that is where their weight was greater than or equal to 2,500 but less than 3,000. And that is our answer. Moving on to the next question. Question 2.1.2 says, calculate the estimated mean weight loss of the race car drivers. Okay, so the estimated mean, it can take quite a while. So let's just first get our table down here and then we'll find the columns that we need to find. Okay, so this is our columns and here's what we need to find. We're trying to find the estimated mean. It's still the mean at the end of the day. So you still need to take all the values, add them together, and then divide by the total number of people or drivers that we have here. We can see that the total drivers are 40, but now our data points, we need to find what those are. It's the estimated mean. So we're going to find this not by taking these individual values. We can't really do that. And that's why we're going to have to estimate. So here's what we need to do. We need to find the midpoint of these weights. Okay, so in each category, we know, for example, there's one driver that lost within 0 to 50 grams, right? That's the weight that was lost. Okay, but instead of saying from 0 to 500, we're just going to take any number there. We're going to just take the midpoint of this, the middle, like taking the average. So we'll take 0 plus 500 divided by 2. Okay, so that's 500 divided by 2, which is 250. So this driver, we're going to classify the weight that he lost as he lost 250 grams. Okay, so that's where the estimation part comes from. So it's the estimated mean. Okay, because we don't actually have these data points. We can't actually physically see in each category how much each driver lost. Okay, and then we'll just do this for the rest. So 500 plus 1,000 is 1,500 divided by 2. That's 750 grams lost there. And this is 2,500 divided by 2, which is 1,250. And then 1,500, that's going to be, when we add them together, 3,500. And then that's going to be 1,750. And then 4,500 divided by 2, that's going to be 2,250. And then 5,500 divided by 2, that's already 2,500 and then 250. So 2,750. Okay, from these you can see that we just keep adding 500. Okay, so the next one will just be, that's 500. And so that is 3,250. And now that we have these midpoints, remember that there are specific amount of drivers in each category. So here, there's only one driver who lost, was saying an average of 250 grams. So here, we're going to actually just take the midpoint and we'll multiply it by the number of drivers, the frequency. And that will give us the total weight lost in each category. Because it's not just one person in each category. Okay, in this case, yes, we have one person here. So the total weight lost here would be 250 grams. But here, where we get an average of 750 in this category, you see that there were two drivers here. So it would be 750 times 2, which is now 1,500. And then we're doing the same thing to all of these. Okay, and then we multiply like that. So these are the total grams lost in each category, okay, depending on the amount of drivers we have there. Okay, so we have this, and this is each of the grams lost in each category depending on the amount of drivers we have. So then you can add all of this up. It gives us 90,500. Okay, in total, 90,500 grams lost. And now we need to find that estimated mean. So to find the estimated mean, this is how we'll find it. I'll just say the estimated mean, and for mean, I'll just say mean, is equal to, we'll take the total grams lost divided by the total drivers. Okay, so that's 90,500 divided by 40 drivers, and that would be the estimated mean. Okay, and that is 2,262.5 grams. Okay, as an estimated mean, and that is our answer. Moving on to the next question. Question 2.2 says, the recording of the weight lost in the second race was made a month later. The amount of weight lost in race 2 was kgrams more than in race 1. It is given that the maximum value of the ogive representing race 2 was 3,504 and 40. Okay, and then the graph was grounded at 4 and 0. And they want us to sketch the ogive, the cumulative frequency graph, representing race 2 in the answer book. Okay, so do you see that? Here they told us that the amount of weight lost was kgrams more than race 1. Okay, so kgrams more. So what is that value of k? We can actually find it here, given what they're telling us. They told us that the maximum now happens at this. So the ogive, right, that maximum they're referring to, the ogive ends up looking like an S, right, like that. And if the maximum is at 3,504 and 40, okay, this is still 40, meaning there's still a total of 40 people, okay? But now it's ending at 3,504. So do you see from this that the last weight that we had, okay, was 3,500. If this is 3,504, it means that 4 grams was added extra. Okay, and then we can also see that and confirm this from this part where they tell us that the graph was grounded at 4 and 0. So where it touches the ground, or this x-axis, is at 4 and 0. 4 and 0 like that. So here, where did it touch the ground before? From the way these classes look, you can see that it had an x value of 0. And this value over here, whatever this is, regardless of whether it's 0 or not, it always goes on the cumulative frequency. It will go with the y value of 0. So it means that this graph would have been at 0 and 0 at this point. And then the highest it would have gone would have been 3,540. But this one is going to 3,504 and 40. And this one is going to 4 and 0. So clearly that k value that they're referring to is actually 4. Because our graph should have looked like this, and it actually just shifted to the right because the k grams was added. Okay, so 4 grams was added. Okay, so it just means that across all the grams, when we're drawing this ogive, we're just going to add 4. So let me take this as it is, just so that we know what we're doing and how we're going to sketch this. Okay, so with the ogive, we're going to need the cumulative frequency. Okay, but this is how our ogive is going to look. Instead of starting at 0, we know it's grounded at 4 and 0. So this is not going to be 0 anymore. This x value, everything increases by 4, all the x values. Because we can see 4 is that k value that was added. K is equal to 4. That is the extra weight added. So we'll say this is 4, and then this will end at 504. And then that will be at 504. And this would be at 1,004, okay, and so on. So this is what it looks like. And now we can go ahead and find the cumulative frequency column. Okay, so this part is really quick to get. You're just going to take the frequency and you're just going to add as you go on. So we first just drag 1 here, and then 2 plus 1 gives us 3. 3 plus 3 gives us 6. 6 plus 8 gives us 14. 14 plus 6 gives us 20. 20 plus 15 gives us 35, and 35 plus 5 gives us 40. And there we go. This is our cumulative frequency column that we have. And now when drawing the ogive, we're going to take it like this. Remember that whatever number is here, that always goes with the y value of 0. These are your x values. And then from here onwards, you're going to take this as the x value, and then the y value is 1. And then this is your next x value, and the y value is 3. And next one, and the y value is 6, and so on. Okay, so here is what our ogive looks like. Okay, just putting down all these points. And you can just label your x and your y axis. So on the y axis, we have the cumulative frequency of the number of drivers, but you can just say cumulative frequency. And then on the x axis, we can just say, since it's the interval of the weight lost in grams, just say the weight lost in grams. And I'm just going to title it ogive of race 2, okay, because this is just the second race. So here we go. Okay, so this is what it looks like. And then we just plot in our values. So remember, these are all the x values on the x-axis. And this one always goes with the y value of 0. That's that point that is grounded, okay, on the x-axis. So that's going to be 4 and 0 that we have there. 4 and 0. And then the rest of the points, make sure you take them with these values. So that's 504 and 1, 1004 and 3, 1504 and 6, and so on, okay? 504 and 1, it's probably somewhere there. 1004 and 3, that will be like in the middle. 1504, and then that one goes with 6. And so it's just higher than 5. And we'll just plot down all our points. Okay, so there we go. This is what it's going to look like. And then you just join your points. Okay, so join all of those. Okay, there. So that is our ogive. And moving on to the next question. Question 2.2.2 says, how will the range of race 2 compare with the range of race 1? So the range refers to the y values. So did the y values change? No. If you look at all the y values, they're still the same. Okay. With our ogive, it stays exactly the same. That's not what changed. What changed was our x values. So we will say they will not change. They will remain the same. Okay, so moving on to the next question. Okay, question 2.2.3 says, determine the average weight loss in race 2. Okay, expected, because they asked you for the range. So they just want to see if you know what changed. Okay, so in race 1, you see, we already found the average. The average was this. In race 2, what changed? So you see that in all the weights, 4 grams was added. But it's 4 grams across everything. 4 grams here, 4 grams everywhere. Okay, so if you found the average of what was added, it would be exactly 4 grams. Okay, you can easily compare this by looking at the new one. If you wanted to find the, let's say, the estimated weight loss in this category, okay, like when we were calculating the estimated mean, you would say 4 plus 504 divided by 2. So that will be 508 divided by 2. And so that is 254. Now you see that when we were calculating the estimated mean, the weight loss in this category was 250 grams. You see that that's just an added 4 to it. So we're just going to take the mean that we already had, the average here, and just add that 4 grams, okay, that has been added because it's 4 grams across everything. So the average weight added was 4 grams. So just plus 4 grams. So that is 2,266.5 grams. And that is our answer. And that is it for question 2.